Welcome to Unit 3, Day 9 notes. Go ahead, pause the video, and see if you can prove these two triangles are congruent. There are a few ways you can do this, so the way I do it might be slightly different than the way you do it, and that might be totally okay. So go ahead, pause, unpause when you think you've got it solved. So, first step is I got to write down my given information. It doesn't look like I'm given anything because it just says prove, but this is where the diagram is important. So I know that segment AB was parallel to segment ED. Segment AC is parallel to segment FD. And segment BC is congruent to segment FE. That is all of our given information. Now, I get to kind of go back and use things from the last chapter. I know I'm looking at triangle ABC and triangle DEF, so I need to figure out some things there. I have no way of finding any more side information, so I have to go with angles. And if I remember my alternate interior angles theorem, I can find that these two angles are congruent. So angle B is congruent to angle E, because if parallel, then alternate interior angles are congruent. Okay, things we've used in previous chapters are still 100% fair game. All right, so I've got a set of angles and a set of sides. So I need to either be aiming for angle side angle or angle angle side. Now, I can't just say angle A and angle D are congruent. I have no way of connecting those, but if I want to, I could extend this line out this way and this line out that way to maybe see that these two angles are going to be related. That's what step 3 is going to be. I can't just say angle C and angle F because there are multiple. So I can say angle ACB is congruent to angle DFE because if parallel, then this time they are alternate exterior angles. So if parallel, then alternate exterior angles are congruent. So now I've got two sets of angles and a side that are corresponding, so I can say that triangle ABC is congruent to triangle DEF by angle side angle congruence. So it's important that I am able to identify the difference between angle side angle and angle angle side, because even if you have everything right in the picture and you put the wrong thing here, it's still going to be wrong because there is a difference. So ABC, DEF, we are good to go. They follow the exact same pattern. So today we're going to start talking about corresponding parts of congruent triangles being congruent. So we abbreviate this with CPCTC. 5 letters. There's not really anything to write for a definition because it means exactly what it says right there. Corresponding parts of congruent triangles are congruent. So when we use this in a proof is pretty much right after we prove triangles are congruent. So that'll be our next step. So for this one, we are given that angle BCA is congruent to angle DCA. Angle BAE is congruent to angle DAE. I'm going to go ahead and mark my picture. So BCA is right here. DCA is right there. So that's angle 1, angle 1. BAE is right there. So I'm going to have angle 2 and angle 2. I want to prove DA and BA. I can't just say that. So my process is going to be prove the triangles that have those as sides are congruent. Now you could set this up a few different ways depending on everything that you know, but I know a triangle that has this side and two angles that I know would be this big triangle down there. So I want to prove those are congruent, or that one's congruent to this one. In order to do that, I need one side length, cannot be this one, of that triangle. So of the 3, there's 2 options. I'm going to pick the one that overlaps. So segment AC is congruent to segment AC by the reflexive property. All right, so that tells me that I've got angle, side, angle. So I can say that triangle. Now, this is where some of us might run into troubles, because normally we could just write down exactly what it says in the proof for proving triangles are congruent. I can't do that now because it doesn't specify a specific triangle that needs to be congruent to a different specific triangle. So you can pick your letters. So I did triangle ABC. So if I'm going to do triangle ABC, I started where there was angle 2, and then went to nothing, and then went to angle 1. So from the top one, it'd be ADC. And that would be by angle, side, angle, congruence, not angle, angle, side. But now, I proved triangles are congruent, so my next step is going to be CPCTC. Corresponding parts of congruent triangles are congruent. See that DA and BA are in the same positions. So I can say those two segments are congruent. So anytime we are using CPCTC, that's going to happen if it says prove something that's not a triangle. You have to use a triangle, so you'll prove true triangles are congruent, and then your next step is CPCTC. Corresponding parts of congruent triangles are congruent. Now, you're usually going to have 1 or 2 steps after proving triangles are congruent if you have to prove something else. Depending on the circumstance, it could be more. Can't really be less, because then you would just be proving triangles are congruent. So for this one, our first thing, we've got AB is parallel to ED, and they are also congruent. I'm going to go back and redo that line segment thing so it actually kind of shows up. So I know that these are parallel and also congruent. All right. Now, this problem, there is a lot of different ways that you can do this because of there's 3 angles, and we are able to find all 3 angles in this case. So it kind of depends on which ones you want to find. So personally, I usually look for vertical angles first. So I would just jump right there and say that angle ACB is congruent to angle DCE because vertical angles are congruent. Remember, when we're naming triangles, the order of the letters is only, when we're naming angles, the only part that's important for naming the angle is the middle letter. When we're naming triangles, the rest of the order matters as well. So even if I proved these 2 triangles are congruent, it may not be ACB is congruent to DCE. So we got to keep that in mind. Now, you could have not done that step and done step 3, where I'm going to say that angle B is congruent to angle E, because if parallel, then alternate interior angles are congruent. They've got to have 2 marks because I've already used 1 mark. Now, you could have also said angle A and angle D are congruent in this exact same step for the exact same reason, because you still have parallel lines cut by, just in that case, a different transversal. If you're having troubles trying to identify these, just extend all of these lines out a little bit. You'll be able to see kind of where they cross, and you'll get your groups of 4 when you're trying to find those angles. But either way, I can now say that triangle ABC is congruent to triangle. And I've got to be careful which route I go. So I went A to B to C, which means I have to go from D to E to C. And this is going to be, for me, I chose by angle, angle, side congruence, because I have 2 angles and not the side between them. If you had done step 3, where I said you could do angle A and angle D are congruent also, and then not done the vertical angle step, then you would have angle, side, angle. And they're going to be slightly different proofs, but they're going to be the exact same idea. So you got to be careful, and that's what makes some of these easy and some of these difficult all at the same time. You've got multiple options. I know some people want to just be able to do exactly the exact same thing for everything, but it's not really going to work out that way. So I need to find that C is a midpoint. Well, my step right after proving triangles congruent is always going to be CPCTC. if I'm proving that C is the midpoint of AD, the corresponding parts that I care about are segment AC and segment CD. So step 6 would be that C is the midpoint of segment AD, which is what I'm trying to prove. And my reason is definition of midpoint. So for all of these proofs in this chapter, it's going to say prove these triangles are congruent. Then obviously you prove triangles are congruent. If it says prove something else, you're going to prove triangles are congruent, and then you're going to use CPCTC. That tells you things are congruent, so you have to have a congruent sign in that step. If you need something else, it's probably because there's going to be a vocab term. Okay, then you're going to use the definition of that vocab term for that final reason. Okay, for the next one. We've got that segment AE is perpendicular to segment AB. Segment AE is perpendicular to segment ED. Segment AB is congruent to segment ED. And segment BC is congruent to segment DC. All right, now I'm going to mark my pictures. I'm going to mark the congruent things first. So AB is congruent to ED. I'll say that's side 1. And then BC is side 2, side 2. I want to just go ahead and mark these right angles, but I need to say that they're going to be right angles first. So angle A and angle E, I can say that because they're the only possible angles there, are right angles. Okay, I'm going to use the definition of perpendicular there. Okay, perpendicular forms right angles. Now, what I technically need to do next is say that triangle ABC and triangle DCE are right triangles. By the definition of right triangles, that should be step 3. I'm not going to be a huge stickler on this one because it's kind of, I view as very obvious. If it's a triangle with a right angle, it's a right triangle. But technically, to be fully rigorous, I need to say that. I didn't have to worry about if these letters were in the right order or not, because I'm just saying, hey, these triangles, not this triangle is congruent to that triangle. But my next step is going to be triangle ABC is congruent to triangle. Since I went ABC, I have to go triangle EDC. Okay, I start at the right angle, go past 1 tick mark, go past 2. Follow that same path. And the reason I can do this is HL congruence. You cannot use angle side side. I hope that's kind of an obvious statement based off of the order of those letters. I'm not going to let you write that in math class. This side 2 was also the hypotenuse because we had found that that was a right triangle. So we have HL. Side 1 was the leg. So right after I prove triangles are congruent, CPCTC, and I need to figure out which sides I care about or which corresponding parts. So I'm finding that C is the midpoint of this piece, which means I want to know that AC is congruent to EC or CE. It's the same thing. And then I want to actually prove C is the midpoint of segment AE. Definition of midpoint is my reason. So again, prove triangles are congruent, then CPCTC, and then if you still have more, definition of the vocab word that was in what you're trying to prove. All right, so another one. Just a whole bunch of examples today. Apparently I'm really bad at making capital R's today as well. Angle DAB is congruent to angle DCB. Segment DA is congruent to segment DC. And segment AB is congruent to segment BC. Go ahead and mark my picture. Angle DAB is this piece. DCB is that piece. DA, DC, AB, BC. Now, AC is completely irrelevant to me in this question at this point. Okay, I know that I have side angle side for this big triangle already. Okay, if I wanted to, I could use a reflexive side and use side, side, side. That's fine. But since I'm trying to prove something about DB bisecting angle ABC, I 100% do not care about segment AC. So my step 2, I'm going to say triangle DAB is congruent to triangle DCB by side angle side congruence. Right? Side 1, angle 1, side 2, side 1, angle 1, side 2. Immediately after showing 2 triangles are congruent, since I know I'm not done, I'm going to go to CPC/TC, but now I need to figure out what part I care about. So I'm showing that DB bisects angle ABC. So I need to know things about this angle in here. Okay, if I'm cutting that in half, that's what I'm trying to do. The parts of that angle in each triangle would be angle DBA congruent to angle DBC. And if I look in the triangles, I went first letter, last letter, middle, first letter, last letter, letter, middle. So they're in the same spot. They are corresponding. So that tells me that segment DB bisects angle ABC. And that would be definition of the vocab term, or we use bisect with an angle. So definition of angle bisector. Again, prove triangles are congruent, then CPC/TC, then definition of the vocab term. Pretty much all of your steps in all of these problems are related to what does it take to prove the triangles are congruent. In this case, we didn't have any steps other than just saying, hey, we have enough already. So if you have longer proof, it's because you had to prove those triangles are congruent in more steps. So for this next one, B is the midpoint of segment AD and segment EC. That is given to us. We have nothing we can mark in the picture because of that. We have to use our definition of midpoint. Okay, if it's the midpoint of segment AD, that tells me that AB is congruent to segment BD. If it was midpoint of segment EC, then segment EB is congruent to segment BC. So these are congruent, and those are congruent. It's possible that all 4 of those segments are the same size, but I don't know that for sure yet. So I have to say with different tick marks. So I've got S1, S1, S2, S2. Now, if I'm trying to prove that AE and CD are parallel, I probably don't really care about that side length down there. Maybe I could use it, depending on what's given to me in different problems. That might be useful, but I can see that I have this triangle right there and right there. So step 3, I'm going to say that angle ABE is congruent to angle CBD, because vertical angles are always congruent. And by doing that, I have enough to say side angle side. I've got 2 triangles are congruent. Now, first triangle you can name however you want. The second triangle, you got to be careful. So I went ABE. So I went past 1 tick mark to the angle and then past 2 tick marks. That means that I need to actually have triangle DBC to follow that same pattern. And they're congruent by side angle side congruence. The triangle is named differently than my angle. That's okay. I could have named this angle DBC and it would have worked out just fine. So it's kind of a, if you know where you're going, you can make sure you're careful about it. Otherwise, just get the angles and then be careful about it as you know more information. So, step 5. We know it's CPC/TC. We want to prove that these lines are parallel. In order to prove lines are parallel, I need to know one of our converses from last chapter. We had the things, if these are congruent, then lines are parallel. So we used alternate interior angles and alternate exterior angles for that. So I could pick any set of alternate interior or alternate exterior angles. In this case, I don't have any alternate exterior, so I need to pick either angle A and angle D or angle E and angle C. Now I said angle E, I said angle D. Technically, I need to use 3 letters for those because even though I scribbled out segment ED, it does still exist. I'm going to choose to go angle A is congruent to angle BDC, and I just picked the 3 letters that were from that same triangle. I could have used these ones as well. Does not matter which set you use, but the next one, your next statement, you can say that these lines are parallel because if alternate interior angles are congruent, then we have parallel lines. All right, so this one we didn't use a definition. We had to use one of our other converses to a theorem, but it's the same basic premise. Prove the triangles are congruent, CP, TC, and then maybe one more step, depending. All right, then there's your homework assignment. Write down any questions you might have and a summary of what we talked about in this lesson. Hope everybody has a great day.